Before class assignment number 16, Hydraulics and Pneumatics. To get 10 points for this assignment, watch the following videos on fluid power. This video explaining before class assignment 16, a video overviewing pneumatic systems, a video on mechanical engineering careers in the fluid power industry. Once you've watched those videos, download CAD models of the following pneumatic components needed for the gang grill: a pneumatic actuator, directional control valve, a 90-degree swivel elbow fitting, a meter outflow control, and a pneumatic silencer. Let's talk a little bit about fluid power. One of the main components in fluid power systems are called actuators. There's a hydraulic actuator. It's basically a piston in a cylinder. And there's a pneumatic actuator. Another important type of component in fluid power systems are directional control valves. Here are a few examples of hydraulic control valves, and here are a few examples of pneumatic control valves. Here's an example of a two-way, two-position valve, a simple ball valve. A way is a port. So if we look at this ball valve, there's one port, two ports. So this would be a two-way valve. And the positions is how many different positions this valve could be in. In this case, there's an open and a close. So this would be a two-way, two-position valve. Here's a three-way, two-position valve. There's a schematic diagram of it. Notice there are 1, 2, 3 ports, so 3 ways. And the valve could either be in this position or that position. Here's a 4-way, two-position. The schematic would show 1, 2, 3, 4 ports with the valve either in this position or this position. Here's a 4-way, 3-position. Schematic would show 1, 2, 3, 4 ports or 4 ways, and 1, 2, 3 different positions. Directional control valves are operated in many different ways. Here's a schematic for a 4-way, two-position. This side of the schematic shows that there's a spring, so if you don't touch the valve, then it spring biases to one of the positions. The other position could be operated by a solenoid. Here is an example of a solenoid controlled but pilot operated. Here's a mechanically operated. Here is a manually operated push button. Here's a manual operated lever. So there's several different ways to operate a control valve. Here is a control valve that has been cut in half so that you can see the center spool. This spool will move back and forth to connect different ports. And these two solenoids are the actuators that will push that spool back and forth. Here are some fancy standard symbols for when you're doing schematic diagrams of a fluid power design. Here's a hydraulic schematic example. Let's take a look at the different components here. There is a schematic for a constant flow hydraulic pump. There are the schematics for the tank. Schematically, it's easier to draw 3 different tanks, but they're all combined into one single tank. This is a schematic of a pressure relief valve. Here's a directional control valve that's 4-way, 3-position, and here's a hydraulic actuator. So let's take a look at how this will work. The hydraulic pump will create flow straight through the valve back to tank. So it's just pumping oil from the tank back to the tank. Once that valve is shifted, however, that allows oil through up to the top side of that actuator. Oil on the bottom side of the actuator is able to go through the valve to tank, and then that actuator will be able to retract. Once that actuator is retracted, it will build pressure because of the constant flow pump. Build pressure until that pressure relief valve is able to overcome a spring and connect and run fluid back to the tank. This is a safety valve so that when we bottom out the cylinder and we build pressure, we don't burst a line, but we have a place for that fluid to go. If we shift the valve to this position, now oil is connected to that port to the bottom of the actuator. Oil on top of the actuator is able to flow back to tank, and so the actuator is able to move. Let's take a look now at a pneumatic schematic example. Pneumatic systems, rather than having a constant flow pump, will often have a source of constant air pressure. Here's a directional control valve that's a 5-way, two-position. With a pneumatic system, we don't need to bring our air back to a reservoir or a tank. We can just vent it to the atmosphere. This particular valve is spring biased to the position that it's shown, so if no one's touching the valve, air will flow through the valve to the top side of the cylinder, and the air on the bottom of the cylinder will be able to be vented, and that cylinder will automatically retract. So if no one's touching this particular valve, it will automatically retract the cylinder. When the valve is shifted, then air is piped to the bottom of the actuator, and the top of the actuator is vented, allowing that actuator to extend. Let's take a look at the principal differences between hydraulics and pneumatics. First of all, hydraulics is an oil, and we treat that typically as an incompressible fluid, whereas pneumatics is usually air, which is compressible. Another main difference is that in hydraulics we even have a pump that's producing a constant flow rate of oil. That results in a variable pressure depending on load and resistance. Pneumatics, on the other hand, are constant pressure sources, which will result in a variable flow rate depending on load and resistance. Hydraulics, we have to have a return flow that needs to return to the tank, and in pneumatics the return flow can be vented to the atmosphere. Those are the three main differences between hydraulics and pneumatics. Let's now go ahead and show you how you can download the CAD models. They're Norgren, all of them are Norgren part numbers. So let's go to the Norgren website, www.norgren.com. They're an international company, so I'll go to their US site. And notice on the bottom that they have online 2D and 3D CAD. So we'll go to that CAD website, and it requires a login. Now most of you probably have never logged into the Norgren website before, so that you would need to say not a member and click here to register your email address. I'm already a member, so I will just put in my email address. Okay, the first thing we'll do is let's go ahead and download a CAD model of an actuator. I know the actuators I want are these stainless steel round line, so I'll go here. And I don't want the ISO standard, that's a metric standard. I will go down to this round line cylinder. That's what I want. And I'll start specifying that I want a double acting cylinder. I want a pivot mount. I want a 2.5 inch bore. I want a 6-inch stroke, 0 for the fractional size. Let's have a rod clevis with this, as well as a pivot bracket. Those will be the brackets necessary for connecting this to our gang drill. We don't need a mounting nut. Let's just have no options. We'll have just the standard seals. We don't need a magnetic piston. We have 0 extra rod extension, and we don't need any thread extension either. And let's leave the port locations as standard. And let's download this in the retracted position. So we'll generate this. Okay, this is what our actuator will look like. It'll have the pivot bracket, the rod clevis, and there's our actuator. Let's download as a step file. We'll hit go and click here to download, and we can save this to our folder in Before Class Assignments number 16, and I'm going to give it a little more descriptive name. This is a pneumatic actuator, Norgren part number, and we'll save that. Let's go back to the CAD home page. Now let's take a look at valves. Let's get a directional control valve. The one we're interested in is one of these manual mechanical operated valves, and we want a Super X, and the valve we want is the X30478. X30478. Hit generate so that we can see, yes, that's the one, the lever actuated, so that I can grab the lever and make my gang drill either move up or down. We'll download this as a step file, let's save that and call it directional control valve. And this one is a 5-way 2-position. Norgren part number X3047822. Go back to our CAD homepage. The next thing we need is a 90-degree swivel elbow. That'll be here in our fittings. Let's go to our fittings, and it's this new fit C style. So let's tell it that we want inch series, C style. We want an elbow connector, a swivel elbow. And we need this to go from 1/4-inch tube to 1/8-inch NPT pipe thread. And let's generate that to make sure it's the right fitting. Yes, that's the right fitting, so we can download that CAD model as a step file. Save this as a 90-degree swivel elbow 1/4-inch tube by 1/8-inch NPT, and this is a Norgren part number. Now let's get our meter out flow control, which is also a fitting. We'll go into the fittings. It's this new fit C style fitting. Again, we're going to choose inch, C style. Now we're going to go to elbows, connectors, and adapters again. Let's now go down to the banjo flow controls. We're going to meter out, which means we're going to control flow out but not in. And in this case, it's a 1/4-inch pipe thread adapting to 1/4-inch tubing. Let's generate that to see if it's the right part. It is. So we'll download, save it as a step file. We'll call this a meter out flow control, 1/4 NPT by 1/4 tube, Norgren part number. Go back to our CAD homepage, and the only thing we have left is a silencer. So we'll go here to the accessories. Let's do one of these bronze silencers. And notice it's only giving me the options for the British standard thread, which is certainly not the one I would buy, but it's close enough in its CAD model that I'm going to download it anyway. I want it to have an 1/8-inch pipe thread. Now notice this is a British standard pipe thread, which is different, so I'm not going to buy this part number, T40B1800. But rather I'm going to download this CAD model because it's roughly close enough. But when I download it, so this is just a CAD model that I'll be able to put in my assembly and have it look decent. And we'll download, save as, and in this case I'm going to give it a different part number, because the one I really want to purchase is a pneumatic silencer, 1/8-inch NPT, Norgren part number MS001A. That's the one I will buy that will actually fit. And the one I'm downloading, even though it's a different part number, British standard thread, at least it will look similar. We'll save that.